Welcome to Master Mathematics in Minutes. Today's topic is the power rule of differentiation, and we'll cover a couple examples on how to differentiate polynomial functions. And we'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is the power rule? For functions of the form y is equals to fx is equals to x to the power of n, the derivative function is given by dy dx, and that is equals to f prime of x, and that is equals to n times x to the power of n minus 1. So there are two steps to differentiate this function. The first step is to copy the power, n, and the second step is to reduce the power by 1, and that becomes n minus 1. For any constant c, the derivative of the function y is equals to fx is equals to c is always 0. And we have dy dx is equals to f prime of x, and that is equals to 0. In the first example, we're asked to differentiate the function y is equals to fx is equals to x squared. So we have dy dx, and that's equals to f prime of x, and that is equals to 2 times x to the power of 2 minus 1. So the first step is to copy the power, and that becomes 2. And the second step is to reduce the power by 1, and that becomes 2 minus 1. And simplifying that, we have 2x to the power of 1, and that simplifies to 2x. So in the second example, we're asked to differentiate the function y is equals to fx is equals to 2 times x to the power of 7. So we have dy dx is equals to f prime of x, and that is equals to 2, which is the 2 at the front, and we will multiply that by 7, multiply by x, to the power of 7 minus 1. Again, the first step is to copy the power, 7, and the second step is to reduce the power by 1, and that becomes 7 minus 1. And simplifying that, we have 2 times 7 times x to the power of 6, and simplifying that further, we have 14 times x to the power of 6. So in the third example, we're asked to differentiate the function y is equals to fx is equals to 9 times x to the power of 10 plus 7. And we have dy dx is equals to f prime of x, and that is equals to 9, we'll copy the 9, and we'll copy the 10 times x, and we'll reduce the power by 1, and that becomes 10 minus 1. And when we're differentiating a constant, that is equals to 0. And again, there are two steps. The first step is to copy the power, and the second step is to reduce the power by 1. And simplifying that, we have 9 times 10 times x to the power of 9. And simplifying that further, we have 90 times x to the power of 9. In the fourth example, we're asked to differentiate the function y is equals to fx is equals to 3 times x to the power of 12 plus 5 times x to the power of 17 plus 99. So we have dy dx is equals to f prime of x, and that is equals to 3. We'll copy the 3, and we'll drop the power 12 to the front, multiply that by x, and raise that to the power of 12 minus 1. And we'll copy the plus 5, and again we'll drop the 17 to the front, multiply by x, raise that to the power of 17 minus 1. And again, when we're differentiating a constant, that is always 0. And so simplifying that, we have 3 times 12 times x to the power of 11 plus 5 times 17 times x to the power of 16. And simplifying that even further, we have 3 times 12 is equals to 36 times x to the power of 11, and plus 5 times 17, we have 85 times x to the power of 16. Again, there's two steps. First step is to copy the power, to the front. And the second step is to reduce the power by 1. So to summarize, the power rule of differentiation states that if you have a function y is equals fx is equals x to the power of n, dy dx is equals to f prime of x, and that is equals to n times x to the power of n minus 1. Thank you very much for watching. This is Master Mathematics in Minutes.